Good morning, everybody. Thank you very much for joining this joint webinar between Renishaw and Metrologic. Just some standard housekeeping rules before we start the webinar. For your information, the session is being recorded. All of your microphones will be muted throughout. And if you do have questions, please feel free to use the question button to write your questions out. And if we have time at the end, we will answer them, or we will follow up following the webinar. After we finish the webinar, it will be available on demand for you to have copies of. So thank you very much, and we hope that you enjoy the following session. So our presenters today are myself, Jonathan Fernberg. I'm the Vice President of Sales with Metrologic Group. And joining me is also Paul Maxted, who is the Director of Industrial Metrology Applications at Renishaw. So our agenda today, we're just going to do a brief overview of Renishaw and Metrologic. We're then going to look at the Renishaw 5-axis technology and running through the capabilities in the offering, followed by a look at the Metrologic Silma X4 offline and the X4 online software solutions, and then looking at both new and retrofit applications with 5-axis technology and the Metrologic Silma and X4 software to leverage the best from that technology. So first of all, Metrologic Group. Metrologic Group is founded in 40 years ago, based in the French Alps near the city of Grenoble. We're the market leader in agnostic metrology software, meaning that our software is not reliant on individual manufacturers' hardware. It can work with the majority of hardware platforms available in the market. We became part of the Sandvik Group in 2018, and this gives us a huge backing and support for our development and our growth and our future. It means that we're able to offer the best 3D control software in the market. We have an advanced universal independent software package. It gives full 3D inspection, programming, execution, analysis, and then full reporting at the end. The solutions are considered to be the standard, the benchmark in many industries, specifically in automotive, aerospace, transportation, but also things like watchmaking, machine building, new energy technologies, and medical markets. Metrologic is based around three main activity areas. The primary activity is our software, and these are the solutions we're going to talk about today. But in parallel, we do have hardware available, and we also offer retrofit and calibration services where appropriate. But today, as I said, we're going to concentrate on the software offering that we have. Metrologic software offers solutions for all areas of your 3D inspection process. Within the inspection process that covers your full production environment, we have our Planner X4 solution, which allows you to prepare and plan your inspection process, including PMI data management. We then have the Silma X4 offline virtual twin software, which allows you to pre-program your inspection and create your test parameter programs. It works with both CMMs and also with robot scanning systems. We then have the Metrolog X4 software. This is the software that drives the programs that are run live. It's a universal application. It can be connected to virtually any kind of 3D CMM, portable device, or even robotized inspection cell. It allows a full geometric and freeform measurement analysis of the parts in a smart, robust, efficient, and simple manner. The final piece of software making up the suite is the Manager Suite. The Manager Suite is a tool that allows you to view the live operational information from all of your test equipment. It also allows you to capture and monitor and manage the efficiency of that measurement process. All of the Metrologic tools can be used either as standalone or as complementary solutions to your existing or each other. So I'll now hand over to Paul, who will discuss and present the Renishaw solution.
Thank you, Jonathan, and hello everybody. And today I'm going to give you a quick background of Renishaw before I go into the 5-axis CMM topic for today. So Renishaw invented the very first touch trigger probe, which revolutionized the CMM industry back in the 1970s. The probe was invented to solve a specific problem around the inspection of some instrumentation fuel pipes for the Olympus engines used on Concorde. Since then, we've innovated and stayed at the very cutting edge of industrial metrology for manufacturers. We started with the basic kinematic touch trigger probes and improved their performance using strain gauge technology. We then introduced capabilities such as stylus changing in racks to add productivity to coordinate measuring machines. Then introduced indexing heads, and our PH10 motorized head has continuously evolved and is still in use on the majority of CMMs made today. And we've continuously developed fixed and modular scanning solutions for use on these motorized heads. More recently, the move to 5-axis measurement technology represents the biggest step change the company has ever introduced. Having developed the original probe for coordinate measuring machines, Renishaw has since expanded its product portfolio to address challenges in and around CNC machining, with the first on-machine probing and tool setting systems, technologies for CNC machine performance monitoring, and more recently shop floor gauging systems to provide control throughout the manufacturing process. And today, we add value by bringing metrology to the shop floor with direct feedback at the point of manufacture. Renishaw technologies allow our customers to boost their productivity through faster setup, improve process capability, and reduce quality costs. On-machine and near-machine measurement systems are critical for the automation of decision-making and process adjustments. And all these systems provide process information which is collected throughout the manufacturing sequence and is a fundamental data source for Industry 4.0. But the focus for today's webinar is around 5-axis systems for coordinate measuring machines. So first, I'm going to explain why infinite positioning of a probe head brings many advantages to CMM measurement. Then, how these 5-axis technologies are uniquely capable of delivering accurate CMM measurement at unprecedented speeds. And finally, how the REVO system is a future-proof platform for multi-sensor measurement capability. So firstly, the advantages of an infinitely positioning head reduce the complexity, the time, and potential for errors in CMM measurement. Because the advantage of an infinite positioning head is that the probe and stylus are always at the right angle and you measure relative to the part. This also means fewer stylus setups, and we have an example of that in a later slide. But the biggest operational benefit of a 5-axis head is the speed at which you can measure. And here's my colleague, Andy Holding, who will explain exactly how this is possible.
Traditionally, there's been a speed versus accuracy compromise when it comes to coordinate measurement machine inspection. Some CMMs can move pretty fast, but when it comes to scanning a part feature, they're slowed right down to minimize any dynamic errors associated with the inertia of the large machine elements. This counteracts any of the potential cycle time gains made by having a fast machine. CMMs will employ either a 3-axis or a 5-axis measurement system. There are some significant differences between the two. With a 3-axis system, the faster you move, the more dynamic errors are introduced to the system. This is because measurement data can only be collected by moving the 3 axes of the machine, and the inertial forces caused by the acceleration and deceleration of the machine structure introduces detrimental effects on the performance accuracy of the system. 5-axis technology, which is only available from Renishaw, moves the X, Y, Z of the machine and the A, B of the head simultaneously. So instead of driving the machine at high speeds and accelerations, machine motion can be smooth and continuous, whilst leaving the head to do most of the work. Over the lifetime of a CMM, the load placed on the moving elements of the machine are much less detrimental to its performance. So when it comes to maintenance, the replacement of items such as drive belts and air bearing assemblies will be less frequent with a 5-axis system. 5-axis technology from Renishaw is available as part of a touch trigger only system with the PH20 probe head, or as part of a REVO multi-sensor system. Each 5-axis system is complemented by a sophisticated motion control system which communicates between the machine and the metrology software to provide fast, efficient data collection. 5-axis systems are used extensively throughout the aerospace, automotive, oil and gas, and even consumer electronics industries. Go to renishaw.com/REVO or /PH20 to find out more.
So we talked about the reduction of the number of styli that are used for measurement. On the left, we see a typical 3-axis CMM setup for a cylinder head measurement, using 8 different tools with 22 individual styli. When we compare this to the far simpler 5-axis setup on the right, you see we need only 5 tools with 1 stylus on each. In practice, this means much more than just reducing the cost of the styli. What we can do is reduce the rack space on the coordinate measuring machine being used for stylus storage, spend less time calibrating the 5 styli before they can be used, and also in your measuring cycle, it means there's reduced cycle time due to fewer rack moves and tool changes in your measuring cycle. So here we have some video footage of the PH20 touch trigger system in action, and as you can see, the head is making all the moves, so therefore it can measure features very quickly. And here you can see the speed at which the head can move between features, because we're indexing to the next angle on the fly as the CMM moves. And this is the REVO 5-axis scanning system, and you can see here with our tactile scanning head and sensor, we can very rapidly move across the part using the head to make most of the moves. It allows you to capture large amounts of data very quickly. And in this particular measuring cycle, you can see the CMM is moving at constant velocity. So this is where we have a laser in the probe, which shines down the hollow shaft, reflecting from the tip, to give us a unique tip sensing capability. As you can see here, the head moves very quickly as we scan the gasket face in automotive application. The multi-sensor capability of the REVO head allows us to carry out surface finish measurement on the same system, the same CMM, where we've made all the dimensional measurements. So here we have the infinite positioning capability of the head to orientate the stylus pickup for faces, for bores. And in this case, we're doing a lateral scan on a bearing journal, which is normally quite difficult to do with a manual gauge. Here we can see that the multi-sensor capability of the REVO system allows us to make surface finish measurements on the same device. And the combined measurement time is less than the dimensional measurements used for comparison. Making all these measurements on one device means there's less weighting, less movement of the part between different devices in the lab, less people, and less floor space. So as you can see, the benefits of 5-axis CMM measurement are significant. I'm now going to hand back to Jonathan to talk about the software that Metrologic have developed for these systems.
Thanks very much, Paul. So having seen the capabilities of the 5-axis probes from Renishaw, let's look at how that can be maximized with using the Metrolog software, Metrologic X4 and Silma offline. We're going to start looking at the offline solution, which is the Metrologic Silma X4 product. This is a software that allows you to generate a virtual twin and allow offline programming. Programming can be a very demanding and time-consuming activity. It requires a lot of focus and attention. And most CMM legacy software uses a DMIS program engine. DMIS is a standard programming code with specific structures and syntax which require a lot of expertise to use. The Silma X4 offline programming and simulation software generates a digital twin, and this facilitates part programming with the advanced smart toolkit contained in the software, which allows an operator to simply and quickly generate a robust DMIS program, which is ready for implementation on your measuring stations. Because Silma X4 delivers a pure DMIS code right up to the latest V5 standards, it's therefore compatible with most measurement analysis softwares available currently on the market. It provides you with smart virtual programming. You can quickly generate your CMM paths. You have potential collision detection built into the software, automatic collision avoidance, and path optimization. These are all options available. So let's look at how we can generate a DMIS part program in the teach mode with Silma X4. So what we're going to look at are some examples of path generation, looking at a plane measurement, which is round the gasket face. In the contouring mode, we'll be looking at measurement of a helical cylinder, and then a surface sweeping measurement. As you can see on the right of the screen, we're teaching the measurement points, and then we have the animation of the actual probe in action, which allows you to evaluate before the program can be used live. What we're seeing is the creation of each feature within the teach panel on the right. So now we're looking at the helical screw thread on the internal cylinder. We will then move across to create a surface to be swept, creating 3 reference points, and then in this case, using the graphical interface to determine the path, but it can also be determined within the parameter sets on the right of the screen. So the measurement in the full 5-axis is completely supported here and can be managed thanks to the graphical manipulator. What you can also see is that within the simulation, the benefits of 5-axis measurement. It reduces the CMM movement, as Paul identified. It saves time, and it allows the probe orientation to be adjusted during the go-to path. Overall, reducing inspection cycle time and improving the accuracy in both the measurement with the reduced flex and backlash in the CMMs. So if you're looking to invest in a new CMM, or if you're looking to upgrade your existing equipment with a 5-axis probe solution, you can also benefit from the whole X4 suite, including the Metrolog X4 software. Because we have an I++ interface, it's direct to the UCC controller. As we saw with the Silma X4, you have all of the programming benefits. But when you install the X4 software, you don't have to make physical changes to your CMM. There's no service requirements, there's no machine calibration, and the Metrolog X4 software can be fully installed and operational literally in minutes. That's why we're able to offer a very easily accessible free trial option. What we're going to move on to now is to look at a scenario where we're using the X4 native program engine, and we will see the primary differences between a DMIS engine and the X4 ngprog language. Metrologic used the ngprog language, which is easily understandable with basic commands built in, and we've translated the software into 19 languages, so it's very easy to roll out wherever you are in the world. One of the primary differences is that there's no imposed structure in the program. You can easily edit and modify every command. An example of this would be if you need to change your probing method. With ngprog in Metrolog X4, you can modify this online. But if you're doing it within a DMIS environment, the operator or the programmer would need to actually erase the command and teach new commands within the DMIS environment. The other primary feature that we operate within the software is that we can manage both the quill and the tip modes that the 5-axis heads provide. For anybody who's unfamiliar with those definitions, it's something that's unique to 5-axis heads. The tip mode is where the head is moving dynamically while the tip remains fixed, and the quill mode is where the center of the head remains fixed while the tip moves dynamically. You can see them both in that video. So moving on to the next phase, which will be probe manipulation and path configuration within the X4 native programming environment. What we're seeing here is we're selecting the gasket face of the piece. The software allows you to customize the probing path. And in addition, you can see there's some orange and some red identifying elements. Those orange and red elements show you that that probing position is actually outside the optimal orientation for the probe angle. So with a REVO head, that's a 60-degree angle to the surface and 45 degrees for a pH20. So where it's red, it's exceeding that value. Where it's orange, it's getting close to that value. And where it's yellow, it's within the optimal probing zone. You also saw in the video that we can easily manipulate the position of the head within the software to bring it within that optimal probing tolerance. Another key feature of the software is if you have multiple features that you want to measure, which are identical but differently positioned, all you need to do is program the first feature, and then you effectively copy the parameters to each other feature within the teaching frame on the right, and that then allows repeated probing of a common feature. One of the points that's absolutely key when you're operating a CMM with an expensive probe head on is that you have some form of collision avoidance with a safety or a clearance box. And if we look at the basic management of these veer point transits between features, we would normally just set up a basic collision avoidance box. This then means that any transit from different faces of the workpiece take place with all of the head and the probe elements being outside of that box. Very simply, it makes for a safe environment, and you completely avoid the risk of any collisions. So just moving from one side of the workpiece to the other. However, within the Metrolog software, we have smart collision detection and automatic collision avoidance options. What this means is that if you select the collision detection and automatic avoidance before you start creating the measurement program, the software will automatically identify if there's a collision risk and build in an avoidance path as part of the program. You therefore have a collision-free inspection program. What you can also do, if you haven't activated the collision detection and avoidance before you create your program, is you can activate it after it's been created, and then the path is automatically checked and, if necessary, modified to avoid any collisions. This is under simulated running conditions. We've been looking at the REVO head. When we come on to the PH20, actually, as with the REVO head, it can be completely managed within the Metrolog X4 environment and the Silma X4 simulation software. Programs can be generated automatically, and they're easily edited as required within the software. When we start looking at special measurement options, one of the features that's available would be a gear measurement solution. With the gear measurement solution as an additional option, we can look at measurement of helical gears with an easily configured programming capability, and all of the gear parameters which are selected by the programmer are actually pre-stored within the software and use the parameters which are defined by AGMA, DIN, or ISO norms. So we have the measurement of the helical gear using reference teeth and then running it out along the number of teeth programmed within the parameters. But in addition, we can do measurement of spur gears, and we can also do internal measurements of helical and spur gears. All of those parameters coming from within the software with intuitive programming. Next, we move on to one of the key areas of any metrology facility, which is the generation of reports, because data is key to what we're working on. Within the Metrolog X4 and Silma, we have the ability to create reports. It's a straightforward and intuitive module which enables the presentation and identification of the measurement results, along with a graphical rendering, as well as deviation and compliance information. We can identify key measurement points of each feature that are being measured on the graphics, but also with documented tables to follow. This is all available with the X4 report editor. The programmer can select the elements of the report, and it's fully customizable. The report can either be printed at the end of the program run, or at the end of a complete working session, the full set of data can be opened in another option, which is the Metrolog iViewer. It's a free option that we have available. So in conclusion, looking at the benefits of the X4 software on a 5-axis CMM system, we have the X4 software offering 3D inspection and end-to-end solutions, either offline or in a full X4 ecosystem. It's backed by 40 years of development experience of a universal agnostic software, the Metrolog X4. We have advanced DMIS and X4 5-axis programming with Silma X4 offline. We fully benefit from the capability of the REVO and the PH20 systems and offer full control. There are also options available for gear measurement. We do options for blade measurement and also surface finish. And when you're looking at outputting the data, we have a fully customizable report editor. Looking at the hardware, the benefits of the 5-axis CMM system are, first of all, speed. It's the fastest accurate measurement solution. You have infinite positioning, the fewest number of styli setups and tools required with no compromise in the accuracy. You also have a multi-sensor capability, which reduces the equipment, the space required, and the total time to verify parts. So thank you very much for your attention. If you require further information, please feel free to contact us. And now we'll open up the forum for questions. Okay, so I think the first question that's come through, Paul, is one for you about the retrofitting. Do you want to take that and let's see how they go through?
Yes, of course. Firstly, though, I'm joined today also by my colleague here at Renishaw, Gareth Tompkinson, who's the Business Development Manager for our CMM and gauging product lines.
Morning.
So the first question was, what is required to retrofit a 3-axis CMM to enable this technology to be used? Well, it's a combination of both a hardware and a software upgrade to drive the 5-axis system. So for this, you require the UCC control system from Renishaw and one of the sensors that we featured in this webinar, the PH20 or the REVO head, and obviously the software from Metrologic.
Okay, thanks, Paul. We've had a question through about, in my presentation, I mentioned about a free trial within the webinar. This is a Metrologic specific question. So basically, upon request, the trial software can be downloaded from the Metrologic website, and we would provide a remote training before the start of the trial period, so you're able to use the software as quickly as possible. With the Silma software, it's easy to use and evaluate, and we can do that at any time. However, obviously, the execution with the Metrolog X4 solution on a physical CMM would only be relevant if you have an existing 5-axis system and UCC controller. So you would need to have that in place, but feel free to ask for that demonstration and software trial.
Okay, the next question is for Renishaw, where most of the video clips of the REVO system showed very long stylus configurations. And obviously normal best metrology practice is to use the shortest possible stylus setup, highest accuracy. Can you explain? So Gareth, I'll hand this one to you.
Yeah, okay, very good question. So yeah, any users who are familiar with CMMs, you want to choose the shortest possible stylus to keep accuracy. With RSP2, that's different. We use something called tip sensing, and that involves firing a laser beam down the center of the hollow carbon fiber tube. So what that means is that laser is now detecting right behind the stylus. And the massive benefit there is it doesn't matter whether you're using a short stylus or a long stylus, the accuracy is very, very similar. So instead of constantly going backwards and forwards to the rack, always trying to choose the shortest stylus, just simply choose the longest one that you need for the longest feature, the deepest feature, and use that for everything. That's pretty game changing, and the accuracy is still there. So the benefit there is the fact that you have obviously fewer styli, fewer calibrations, your cycle time's up, and when you combine that with the very fast scanning speeds of the 5-axis system, that's what gives you these colossal improvements in throughput. Okay.
Thanks, Gareth. So we have another question in on the Metrolog software question. It was something we touched on very, very briefly in the webinar. The question is the X4 software able to support CATIA V5? The simple answer is yes, it is. Metrologic is a Dassault Systems partner. So the X4 V5 and Silma V5 software is available for both online and offline solutions, which offers an embedded solution with a seamless workflow. So it's working directly within the CATIA V5 environment. The solution is fully compatible with CATIA, Enovia, Delmia, and other V5 solutions. As we said, it's available fully available as an option within the software.
Okay, another question here for Renishaw. How flexible is the PH20 touch trigger system in respect of stylus configurations? So the answer to this is the PH20 uses all the standard TP20 modules that are available. So you've got the modules with your standard force, your medium force, extended force, 6-way that you'd expect to see on a traditional CMM configuration, and also the extended modules EM1, EM2, all compatible with the standard rack changing capability. So if you're using TP20 configurations with an indexing head, all those configurations could be used for the PH20.
Thanks, Paul. Now we've had a question through about PMI data and whether that can be handled in the X4 software. So yes, the X4 software does support embedded PMI data from CATIA, Siemens NX, Creo, and STEP formats. The data can be imported and it can be then used to allow advanced D&T analysis. It does depend on the Metrolog software configuration as to the degree of that capability, but yes, it can support it. So we have a couple of other questions. I think we only have 1 or 2 minutes left of our session this morning. We do have a question about whether the webinar recording is going to be available on YouTube or other platforms. At the moment, that hasn't been defined, but we will advise everybody whether that's the case. I think, Paul, that a question also come in about the size of parts that you can work on.
Yes. Question here in the demo. All the products shown were quite small. I have products over a meter long. Can I still use the probe? For the REVO, yes. We have a RSP3 head, which allows you to use very long stylus extensions. So one of those parts in the video was actually a very large engine block for a truck. So parts over a meter long, depending on how far inside fish you want to get, but we can definitely access much bigger parts than shown in the video.
Okay, thank you, Paul. I think we're running up against our time limit now, unfortunately. We do have other questions that have come through. We know everybody who's asked the questions, so we will get back to individuals with answers to their questions. I'd just like to close the session then by thanking Paul, thanking Gareth, and thanking the team that have assisted us with putting this webinar together, and thanking everybody who's taken the time to attend and watch our presentation today. So thank you all very much, and hope you have a good rest of the day, everybody. Thank you.
Thank you, everybody.
Thank you.